Hey, everybody, welcome to the show today. Today, we're going to talk about what it really means to grow fruit trees naturally. At first, when I first was starting to grow fruit trees, I thought growing fruit trees naturally just meant you aren't using any chemicals, sprays, and you just leave the tree alone and let it do its thing. But one of my very first fruit tree care mentors was the wonderful Norm Herbert. And Norm said to me, Susan, I need you to know something. Growing fruit trees organically isn't the same thing as neglect. And all these years later, I still remember what he said. So, growing fruit trees naturally means a lot of things. It could mean building the soil, or pruning wisely, or creating the right environment for a healthy fruit tree and a productive fruit tree. And so in the show today, I'm going to be chatting with Lindsay Engers. He's the owner and grower at Chiltern's Heritage Orchards in the United Kingdom. And our question is going to be, what does natural fruit tree care actually look like? So I'm going to talk to Lindsay in just a moment. But first, what are your thoughts about growing fruit trees naturally? Do you have stories to share or ideas? If you're watching us on YouTube, be sure to pop your questions and your comments into the chat box, and we will reply as soon as we can. So now, Lindsay, welcome to the show today.
Hi, thanks for having me on. It's great.
I am so glad to chat with you. And so I want to start with the basic question. When people talk about growing fruit trees naturally, what does that mean to you?
I think the most important thing to remember is that plants have an inbuilt ability to grow really well if you satisfy all the criteria they need. And the most important thing for me is to make sure the plant's got no attenuation. In other words, nothing's holding it back. So natural growing really involves using the microbiome in the soil, the microbiome on the leaves, and I'm sure we'll get into the protocols that we use.
So, working together with nature. And, I've been doing this for 15 years. And at first, I feel like, I really was feeling my way around, but not really not looking at the soil. Is there life in the soil and things like that? Now, do you consider yourself a regenerative grower? And if so, what does that mean?
Well, I think regenerative growing is a very broad term. It covers not just organic growing, and I'm sure we'll talk a bit more about what organic growing is. It's also about regenerating the carbon in the soil. It's about regenerating the health of the environment, also the local economy, the local water systems. It's much broader than just your crop. And I think that definition works really well. You see it as part of a agricultural system in your area.
So, how does that compare to organic growing? What is organic agriculture
Well,
then?
I think that's a very good question. The way we grow at Chiltern Heritage Orchards is based upon three basic principles. And we are certified organic, we are Soil Association approved, and that does mean, obviously, that we satisfy their criteria. But you can be organic and still do some pretty destructive things. Um, and well, the other thing that we use, which is a very important part of our ethos, is being ecological. So being ecological is actually using the natural microbiome in the soil, applying certain products that are benefiting the soil, which in turn then benefits the plant. So we use basalt rock dust and we use foliar sprays of organic approved seaweed. And they are biostimulants. We don't use fertilizers. You can be organic and be quite harmful. And the third thing that we use is this idea of using historical varieties and historical techniques like grazing. So the way I look on it is a kind of three-way partnership between those ideas, and that adds up for us to be regenerative.
Okay, give us a picture of I know you grow lots of different things, but let's focus in on
Yeah.
fruit trees. What fruit trees do
Okay.
you grow? How many do you have? Tell us a little bit about that.
Okay. Well, we started in 2016 with the idea of effectively being a cider and perry orchard, and we started off planting about, I think we had seven varieties of perry and about 20 varieties of cider apple, roughly, on an area that was roughly a third of an acre, tiny amount, on old pasture land. And it was very quickly obvious to me that there was a very oversaturated market for cider production in the UK. It's very difficult if you're small to actually find a market. They did the worst thing possible. You start a business with no clear idea who your customers are going to be. And I don't recommend it. But we very quick. I always knew there would be a market for heritage fruits, so we very quickly expanded into growing the really rare and the almost forgotten and the almost extinct varieties. So we grow lots of different apples, both dessert cookers. Most of them have got 2 or 3 uses, so they can be juicers, they can be cookers. And then we also grow loads of different dessert and cooking pears. We grow a class of pear called a Warden, which is virtually forgotten about, which is kind of the ancestor of a lot of the more modern pears, but in fact was used before potatoes became mainstream. And it's very, very useful for people who suffer from, leaky gut syndrome and things like that. They can eat these sort of potato substitute fruits. So we're discovering the uses for the old pears. And then we grow lots of damsons and greengages and loads of different rare plums, really strange sounding ones like Winter Crack, which is mentioned in a poem by D.H. Lawrence and was only found in one garden. We grow some really obscure greengages. I'm doing a lot of greengage trials. And then we're growing lots of quinces, medlars, the almost extinct Neapolitan azaroles, Chinese azaroles. We grow all sorts of different rare, almost extinct hybrids, so dams and plums. And of course, we grow a lot of cherries and other fruits which are sort of difficult to describe, but somewhere between the dams and a bullis. Some really, really interesting varieties, hundreds of varieties. And we've just recently expanded into a much larger orchard, a lot.
A lot. That is so exciting.
Yeah,
If you were a conventional orchard, you would be buying in a lot of fertilizers, I would
yeah,
assume.
yeah.
Do you spend a lot of time bringing in and buying in fertilizers from outside?
No. I mean, one of the most exciting things about being organic is the amount of restrictions that you have put on you. And our protocol is based upon the concept of microbiome nutrient delivery. So the basic concept is that the soil itself has many minerals in. There's a ton of phosphorus there that's free of charge. There's a lot of potential nitrogen that can be obtained through bacterial assimilation fixation in the soil. So we don't really spend much on what we would call the NPK, the nitrogen, phosphorus, potassium. Potassium also comes from the soil. But what we do apply is about 70 grams per year of rock dust, which is organic approved. So that's volcanic dust from Scotland, and that's per tree. And then we do about 4 or 5 foliar feeds on the fruit trees with, it works out about 5 teaspoons per gallon of seaweed extract. So you can see the nutrient inputs are incredible. They're not sufficient to get a crop. There's not enough there. So it's obviously coming from somewhere else. And somewhere else is the soil. And I think that's the most exciting thing.
So I'm just going to filter out what you just said because that's kind of
Okay.
amazing. Until
Yeah.
now, for a generation at least, if not more,
Yeah.
we've been focusing on NPK, nitrogen, phosphorus, potassium.
Yeah.
And so you buy bottles of this stuff, you buy fertilizer spikes, and it all is about NPK. But what
Yeah.
you're saying is there is the P and K are already in the soil, right?
Most of it. I mean, very small amounts are applied. Yes. Yes.
So,
Most of it's there already.
it's in the soil.
Yeah.
Nitrogen may be in the soil, may not be in it. That's often a problem.
Yeah.
But you're saying we can get rock dust, which doesn't have NPK in it, and we can feed our trees with rock dust. How does that
Well,
work?
okay. So the first thing, what is not in basalt dust, and this is stuff that's millions, billions of years old. This is volcanic ash. What is not there is nitrogen. So the first puzzle is, well, how could you be feeding a tree and making sure you get big crops? And we do get good yields. We get big yields. We're selling large quantities of crops. Where is it all coming from? Well, the air is 79% nitrogen. If you feed your soil with the right trace elements, and the key one actually is molybdenum, you can then fund a free of charge delivery service, which is basically nitrogen fixation by things like azotobacter, which live in the soil. They just need enough trace element, particularly molybdenum,
But
but
not
not
only.
only. You also get the nitrogen fixing nodules on legumes, so we have vetches in the meadow and under the trees. That funds the nitrogen problem. So it's delivered as protein. That's a very, very important part because if you deliver nitrogen naturally in this way, you're basically borrowing the technique that's used by woods and hedgerows. And that's what we do. We're not delivering nitrogen in an artificial way. So it comes in as protein, and therefore the plant doesn't have to convert it into anything. It's not taking nitrate or ammonium. So you cancel out all the problems of aphids and chewing pests because they can't digest the sap of a tree that gets its nutrients through, or particularly its nitrogen through that system. The rock dust does have phosphorus, does have potassium. So, there's a lot in there, but it comes out very slowly.
It comes out very slowly. Okay, so let's go back. We have 75% of the air that we breathe is nitrogen,
79,
you're
yeah.
saying. Is that, am I right?
79. 79, I
79,
think. 79,
79% of the air
I
that we
think is
breathe.
the correct figure. Yeah.
Okay, lots. A
Yeah.
big
Yeah.
percentage of the air that we breathe is nitrogen. We want to
Yeah.
get it into the soil, and you're suggesting that with things like plants, cover crops that are nitrogen fixing, we can
Yeah.
snatch that nitrogen from the air
Yeah.
and pop it into the soil in a way that the soil organisms can digest.
Absolutely.
Now, you mentioned, is the first thing you mentioned, was that a specific soil organism that turns nitrogen into like that somehow snatches nitrogen from the air
Yeah.
and makes it into plant available form? What is that? What is that little microorganism called?
Azotobacter. And the thing about Azotobacter is it's a very ancient organism which occurs naturally in the soil all over the world, and it's part of an industry in a process actually of nitrogen fixation that naturally occurs in undisturbed land, woodlands, hedgerows, etc. What kills it off is nitrogen fertilizer. So if you apply nitrate fertilizer, for example, ammonium nitrate or nitrates generally, or heavy applications of manure even, which have nitrates in, you will wipe out the azotobacter, the nitrogen fixer that can supply your trees with as much nitrogen as they need. Now, that's actually not well known. But if you study soil, and I've been lucky enough to study soil for a long time, you'll know about azotobacter, you'll know it's important. But it's always been sort of missed off. It gets forgotten about. But it is the nitrogen delivery system of choice of the natural world. And of course, the cover crops and the grazing, etc., recycle the nitrogen back into the soil, but they don't necessarily add a huge amount, but they add a little, and all of that goes into the plant. What's really interesting, and I think the point that will interest your viewers the most, is the fact that it has a huge impact on pest and disease control, and also water, because if you supply nitrate or ammonium to trees as a fertilizer, the tree will need 3 or 4 times as much water. We don't irrigate, we don't have to, because our trees have a very powerful microbiome which delivers the water during drought. So we don't have a problem with drought. So not only the pest and disease avoidance that you get with this system, it's also the need for irrigation.
Let's go back to this idea of NPK. So the whole idea of that we've been kind of following for decades that you need enough NPK. It is measuring the synthetic stuff to see if you don't have those organisms in the soil, if you've already killed them off, this is what you need to feed your trees, right?
Yeah,
And so, what we're trying to do now is to get the trees unhooked from that sort of addiction of external NPK or synthetic NPK so the soil can feed it naturally. You talk
yeah,
about the microbiome. Is that similar to what we talk about in human bodies in terms of our
absolutely.
digestion? Can you compare the two there?
Well, I think it's a great comparison to make. And there was this old adage, healthy soil equals healthy crops equals healthy humans. And I think it's very true because the microbiome in the soil, which is not only external to the roots and lives in the soil, is also within the roots. And in fact, we've now discovered that bacteria and fungi populate the entire plant inside and out. And a very healthy plant will promote uh, a very healthy plant will be supported by a very healthy microbiome in exactly the same way that a human gut system of health works. So if you've got a very healthy microbiome in your gut, you generally have a better physical and mental health than somebody who has a poor microbiome.
So I'm actually seeing it as we humans, we have our microbiome inside our bodies, like the whole digestive system, but it's almost like the plant's digestive system is outside its body, outside its
Yes.
roots. And
Yes.
but it also relies on these wonderful organisms. So let's go back to your actual routines to look at it practically. You've got your trees in the ground. Do we want to start with preparing the soil before you even plant them? Do you need to do some preparation to get the soil into the kind of situation where it can support trees?
I think it's very important that you've raised a great point. If you're starting with unimproved grassland, which we always luckily have, where nothing's been added for quite a long time, there's not been ploughing, we've had basically a cover crop of grazed grass, then your soil preparation is pretty minimal. So I can tell you what we do for that first. We dig a hole that's big enough to support the root system, but not too big. We remove any rocks. We put the turf to one side from the top, and I should say, actually, we line the hole with chicken wire to prevent voles getting at the roots. And we then backfill with the soil that we've dug out, taking out any big stones. Because in the Chiltern region, anyone who lives there will tell you there's generally a lot of flint, which is which is a silicon dioxide rock, which has its benefits. So we take those to one side and we store those. And we put the tree roots into this vole cage, effectively, of chicken wire mesh. And then we backfill with some soil. But before we do that, we add two things. One is a mycorrhizal preparation called root grow, which is effectively a probiotic, or a biotic preparation with all sorts of bacteria and fungi in, which inoculates the roots, helps them establish. But also, we always put in a pinch of rock dust. And that is it in terms of soil preparation, in terms of additions. Then we put the soil back and we keep the best soil. We put the best soil around the roots, so all the soil that was from the top. And we keep the very top grass part. So we wrap the whole roots in the chicken wire. We put a membrane over that, a semi-permeable membrane that lets rain through. Then we cover that with the turf upside down, and then we put any stones that we found on top of that. And what that does is it ensures that the tree won't be attacked from below by various voles. We have different vole species in the UK, which are very destructive. If a badger comes along looking for anything, it tries to dig the roots out, it can't. And then the membrane gives us about a month's worth of rain. If we go, we've just had a very severe drought, and then our newly planted trees have come through that, almost all of them, with no additional water. I think we watered the quinces once, and that's our system. Very, very basic. So that's a paddock system. That's a kind of the best. Yeah.
And
But if
how
yeah,
big are these holes? Like how much of this chicken wire do you need? Because obviously the roots start small, but they're going to expand and expand.
absolutely. And what's interesting is that these chicken wire enclosures, just to enclose the root ball or the pot or the bare roots, they're not big. They'd be about, I don't know, maximum would be a quarter of a meter square, a quarter of a square yard, something like that. So we wrap the whole thing up. But that eventually will degrade over time. Maybe in 5 years it will be degrade and become, it'll allow the roots to escape. And we found the roots actually, when we have dug up trees in the past occasionally, where the roots have grown through this absolutely perfectly. Very much like a root ball tree, where you buy a root ball tree in the UK and it's wrapped in a chicken wire cover and you never take that off. So the chicken wire isn't really a barrier to root growth. Um,
But but the chicken
it
wire
is a
is made out
barrier.
of metal, and so it wouldn't break down, would it?
Well, it's surprising actually how it does degrade over time. Not immediately, but it's galvanized iron, so it's got a zinc coating and then it's got iron, and
Mm.
eventually it rusts away, it disintegrates. But it takes a long time, and those are not toxins. I mean, those are very slight. I mean, elemental metals. In fact, zinc and iron are very important for plant health, so they're additional sources in the long term. So
And
they're actually great.
and and what is the membrane you put on the top? Is it fabric of some sort?
Yeah, I mean, we would call that in the UK, we would call that an extra heavy landscape fabric. It's something that you put underneath on the floor of a polytunnel. You might use it if you're putting down foundations and you put hard standing on top. It's interesting. It works a bit like a semi-permeable jacket. It breathes, so it lets air in and out. It lets water through one way, but it doesn't let it escape. So if you cover a piece of ground with it, it excludes light. And in fact, it's a very good way of creating weed-free ground. But it does retain moisture and it allows the roots, particularly in the early years, to survive some pretty severe droughts. We've trialed it over many years and it's been a brilliant addition. It's a game changer because it means we don't have to have an irrigation system for the young trees. And
And
once the trees, yeah, get going, they're fine.
considering that this is organic growing, that landscape fabric, I guess it's not made out of organic materials. Is that a no-no? Is that a challenge for organic certification?
No, actually, it's not. I mean, it's no different to growing in a plastic pot. It's because it's non-biodegradable. It's not a biodegradable product. It doesn't it doesn't fragment. And in fact, because it's covered, it never receives any UV light. It doesn't break down in the soil. It sits there for many, many years. It does not deteriorate. You can dig this stuff up in 20 years. It's still there, still fine. You can wash it
Interesting.
down and reuse it.
So,
So
okay,
yeah,
so I'm picturing in my mind's eye what we've got. We've got a nice size hole. You've
yeah,
got your roots, the bare root tree put in there. You're
yeah,
backfilling with the best soil, not adding anything except for a little mycorrhizae powder and a little bit of rock dust.
yeah,
You are gently tamping down the good quality soil. Then
yeah,
you put the landscape fabric on top
yeah.
of
Well, you
that. Am I right?
yeah, you wrap the chicken wire over the whole of that finished root ball, if you like, and then then you put more soil on, and then you put the landscape fabric on top of that. Then you put more soil and the turf inverted and the stones. So the whole thing sits there and sits out the drought, sits out the cold. It protects the roots from ingress of rhizomatous grasses because the grass comes up to the tree. We don't have cleared patches around the trees. We have long grass right up to the trunks. So it just helps with establishment. Very successful.
Amazing. Amazing. Okay, so you've got your grass growing right up to the trees. Is there a problem with, mowing, clearing away that grass so that there's good air circulation around the trunk as it grows higher? How do you deal with that?
Well, I think it's a really interesting question. Michael Phillips, the great orchardist, the late great Michael Phillips, wrote in one of his books about the difference between mown turf and long grass around trees. And what you find is that where you have long grass, where nobody cuts the grass, maybe they graze it, but they allow it to regrow, the root system of that grass penetrates very deeply and creates a huge amount of airspace and percolation and crumbliness in the soil, which is great. So you don't get the roots being impacted by the buildup of CO2 or a lack of oxygen that they need. If you mow the grass around the tree, the opposite happens. The root systems of the grass become very compacted, and it forms a kind of plug or a plate around the tree roots, and it does impede the growth of the tree. So it's interesting. Long grass, grazed grass, not a problem. Short mown grass, big problem.
So basically, because the animals are taking care of the mowing for you, you
Yes,
don't
in most,
really
well,
have the same problem that maybe an urban backyard would have, having grass growing up to the tree. Yeah.
Yeah, I mean, I think if you were to do it at home and you let your grass grow high around your tree, you'd probably be surprised it didn't really make a big difference to your tree. I think if you were mowing the grass in your urban area, you would notice because you're taking away a lot of nutrient and you're creating a different root system. So yeah, it's an input. Yeah, you can mulch around trees. I'm not against mulching. It's just very difficult for us to do that on the scale we operate at.
Exactly. Like as a home grower or, with our small community orchard, we bring in compost every year and we have big, beautiful mulch circles and we feed our trees that way.
Yeah.
We have never used rock dust. And years ago, I remember going to some show and somebody selling this or giving away little samples of the rock dust. And I remember
Mhm.
researching it. Now, this was many years ago, and maybe on the internet there was things saying, "Oh, that rock dust, it's going to take 1,000 years to break down, and so that you can get the components to the plants." So, what would you say to that argument that, you know, doesn't rock dust take a long time to break down?
I think it's a great argument. And for a very long time, everybody thought that. I thought that, that rocks were rocks and they're there as a kind of an inert substrate. We had a very kind of chemical view of the soil. And we discounted the power of biology to dissolve minerals. So it's been proved. And in fact, I think Dr. Elaine Ingham, the soil food web lady, has actually been discussing this on some of her podcasts where they've discovered that bacteria can break down silicon dioxide. They've discovered that bacteria can create acids that can mine out phosphorus that's in an insoluble form very rapidly and then transmit that through fungi. So the idea that rock dust takes thousands of years to break down is kind of not true. Yes, it's not soluble. If you shake it up in water and you measured the water, you wouldn't find much dissolving of that because it's a mineral. But the minute you introduce biology, particularly bacteria, whose sole job in nature is to dissolve out minerals and pass them on through the food web, you notice that within a year that rock dust has transferred. I've seen trees fall over with the weight of crop just using it in one year. I mean, I don't work for a supplier. I've got no I should declare I've got no links to any suppliers of any of these products, but I was quite surprised how rapidly things change. And of course, when you look at the world where plants do well, it tends to be in the volcanic soils. It's where the most productive land is. So it's not a
So,
great surprise.
so the rock dust we're talking about is not me going into my backyard and somehow grinding up any rocks I find. This is specific type of rock. What type of rock
Yeah.
is it and why is it special?
Well, I think what's really interesting, if you were to imagine the planet as a fruit and you sliced it in half, you'd have the outer crust, which is the earth that we live on, the surface. But below the surface, there's this whole molten magma. And that molten magma has got pretty much most of the nutrients, or all of the nutrients that we need in it. Not nitrogen, but pretty much everything else in a molten form. And occasionally that erupts as a volcano, and we see this stuff deposited on the land, and it gradually dries up. If it's deposited in certain forms and it dries up quite quickly, and it's eroded quite quickly, we call that basalt. So it's a volcanic material, and the basalt has all the major nutrients and the minor nutrients. They're very discounted. The zincs, seleniums, all the iodines, and things that are basically missing from our diet are found in volcanic ash and volcanic dust. So when you apply that to the land in tiny amounts, because they're only needed in tiny amounts, they're rapidly moved through the ecosystem by bacteria, fungi, and funny enough, earthworms that love it when you add volcanic dust to the soil. Everybody loves it in the soil because for them it's natural. It's their natural source. I mean, the planet was once a volcanic husk, and it's plants that have created the soil. It's plants that have managed to create this, but they've used bacteria and fungi to do it, working with the volcanic material. So it's kind of we're just taking it back to the first principles.
So if I were to, okay, when, we've got our community orchard in the local park and I want to get the benefits of this rock
Mhm.
dust,
Sure.
um, what would I do? How much would I put out? How much would I sprinkle around every tree? Is there a special way
Yeah.
to apply it?
Well, in fact, what's interesting is because it's slow acting, you could apply it any time of year, but the best time to apply it seems to be in the autumn. That's when we apply it. And I put roughly a handful, which is roughly about 70 grams, around each tree, and I just sprinkle it around once a year near the trunk, not right against the trunk, because most of the feeder roots on an apple tree, as I'm sure you have explained many times, are quite a long way from the trunk. So it's important to spread that out onto those feeder roots. And if you do it in the autumn when the roots are actively growing after leaf fall, they'll take up a lot of that through the bacteria over the winter. If not that autumn, the following spring and the following autumn, you'll suddenly notice a tree that totally changes. I mean, I can tell immediately a tree that's been fed with it because the leaves are thick and waxy, they're oily, and they're a different color. They're slightly pinky. So it's
So
fascinating.
that it also sounds incredibly game changing. And I wonder, like in my imagination, I'm wondering, well, why the autumn? Why is that a good time? Maybe that's when the microorganisms are active that consume the rock dust or something, who
Yeah,
knows?
I think well the way the trees work is that and we've talked about this before lots of times on videos on YouTube. What most of the tree makes in terms of sugar, it pumps into the soil, and it does that during the spring and the summer particularly, but in the autumn as well. It pumps out a lot of sugar to feed the bacteria and the fungi, and it sends out messages and it tells the microbiome what it actually needs through its root system, and then the root systems are supplied through the fungi and the bacteria with what they need or what the tree needs. So I think the autumn and the winter are a good time to do it because certainly up until the shortest day in the UK, the soil's still quite warm and there's a lot of microbial activity around. Uh, but it's quite interesting how you see the trees change over
Amazing.
perhaps a year.
With regards to
Yeah,
what you were saying about how trees, they photosynthesize, they enjoy the nutrients that they are creating through photosynthesis, they use it themselves, and then they
yeah,
release some of those nutrients into the soil, which feeds the microbes in the soil. Microbes come running saying, wow, that's yummy, delicious buffet. They eat
yeah,
all the good exudates that come out of the tree and then they die and they consume organic matter and then they feed the tree. It's this beautiful cycle. For listeners who want a reminder about how that works, go back to the episode of my podcast where I interviewed John Kempf because he
Yeah,
explained that so beautifully. And
yeah,
again, I feel like through this podcast, I am incrementally understanding the magic that is happening really in the soil. You talk about earlier, you mentioned how we used to have a very chemical viewpoint around farming and agriculture and growing plants. All you need is some soil and some NPK and a plant and put them together and everything's good. But then you get pests and
yeah,
diseases and all sorts of problems. So what we're saying is it's a little more complex than that. But if we know how to work with nature, nature will supply the trees and the plants with what they need.
yeah. I think
Yeah.
that's it. And the great thing about John Kemp's work has been this plant health pyramid, where he explained very clearly that if you can base your nutrition program on bacterial and fungal inputs to the roots rather than ammonium and nitrates, etc., and what we would call inorganic ions, then that makes the plant able to photosynthesize much more efficiently and develop a much higher level of immunity. So suddenly it doesn't get aphids anymore because it doesn't have nitrates in the sap, because it's able to get rid of ammonium out of the equation. It doesn't get mites. You don't get red spider mite. If you can go up a bit higher, you produce immunity to beetles. So plum curculio might be very important to you, or we have clay-colored weevil here. What's really interesting is we suffer from really very low pest incidence, and I think part of that is the fantastic work of the idea of the plant health pyramid, but also another part of our work, which is the ecology. We have these wonderful helpers, these free of charge helpers, which are either pollinating or predating. So if an aphid does turn up, and the plant immune system lets a few through, the ladybirds and the hoverfly larvae, and the shield bugs and the capsids, rather, all of the things that are sort of predating, just waiting, the blue tits, they come in and clear up the remains. So we have no caterpillars, we don't have codling moth, we don't have sawflies. And you would say, well, this sounds like a dream world. This sounds unlikely, sounds improbable. But actually, I've seen it at first hand in other places. I was lucky enough to work for National Trust for a while, working with my students at Hughenden Manor. We saw that firsthand. When you stop spraying, when you don't spray, you suddenly see nature producing amazing fruits, and that's really where that was the observation. You talked about observation very early on. I think observation is very, very important in what we do. It leads to all these amazing revelations.
Beautiful. Yeah. So, and with regards to what you were saying about how, in a different episode on the show, we'll link to it in the show notes. We did an interview about why healthy plants, why pests are not attracted to healthy plants. Pests do
Yeah,
not attack healthy plants. So, the healthier that we can get our plants, the better and more pest resistant and disease resistant they are. And it's really cool to know that this rock dust can be a part of the equation. One of the principles of regenerative agriculture is to keep the ground covered at all
yes,
times. And I
yes,
remember in my interview with John Kempf, he was saying, if you need to weed a bed, just take out the 1 or 2 or 10 weeds, leave everything else.
yeah,
Um, and that has been kind of game changing for me in the sense that with my own veggie garden, I used to clean up the bed at the end of the season and then just leave the bare soil. And then
yeah,
the winter came and snow. I thought, well, it'd be insulated by snow.
mm,
And then in the spring, I dig in and I never found worms. Like it was just never worms in those beds.
yeah, yeah,
2 years ago, we started to grind up our leaves and neighborhood leaves, and we did a beautiful thick layer of leaves on our veggie beds that
yeah,
we laid out in the fall. And in the spring, we sort of pushed the lide and dug into the soil, and it was started to be filled with worms. Like it was incredible. The
yeah.
following year, we planted cover crops in those beds, as well as doing the leaf mulching. And the worms are crazy. There is so much going on. There is so much moisture in the soil. So can you explain to me why is it important to cover the soil at all times?
I think in nature, where soil is bare, it does oxidize rapidly and it promotes a kind of aridity, and it diminishes the activity of the bacteria and the fungi. So that I think that can happen through the sun, or dehydration, or obviously in our case, tillage and application of chemicals. So the minute you have bare soil, you're promoting oxidation. The minute you cover the soil, with leaves or cover crops, you're preventing that sort of self-destructive oxidation happening through the sunlight or through drought. But you're also introducing a lot more carbon. And once you do that, you're providing a food source for the bacteria and the fungi. So you'll prevent, and that in turn, they are very, very good at reducing oxidation if you promote the right ones. So it's a great
It's
healthy soil then.
Lindsay, it's so funny because in the early years, we did things like double digging, which is like digging
Yeah,
up the soil, flipping it upside down, because
yeah,
somebody
yeah,
told us you were supposed to do that. And we kind of did everything wrong, but to see the difference it makes is quite astounding. So in terms of covering the soil, we talked about covering the soil with like leaves just to protect it. I know that some farmers will even take all their weeds they've dug up, whatever they've got, if it's a big space, they just pop it on the soil to protect it.
yeah.
But what about cover crops? What's the role that they play?
But I suppose if you were to look back in the history of how fruit used to be grown, one of the things that was done, I think Canada and possibly the US as well, when they planted an orchard, they quite often used to plant buckwheat just before and during the first sort of establishment of the orchard. So they knew that buckwheat was very, very good at promoting what they would have thought as healthy soil. So I think the role of cover crops is either there's two things you can do. One is what we call a nitrogen lifter, which pulls up nitrogen that's already in the soil and recycles it. And the other ones, of course, are the nitrogen fixers. And both of them are very good at improving the soil organic level, but they also improve the percolation of the soil, the breathability, if you like, the air, the airfill porosity of the soil. They make the soil healthy for the roots. The only thing I would say is that cover crops can be short-lived. And one of the things you could consider, and I have seen this done, is to use a perennial cover crop. So something like Spanish comfrey, which we've used in parts in our permaculture section of the orchard. Spanish comfrey is an incredibly interesting cover crop because it promotes all sorts of health benefits, which I'm not sure if you've come across that one.
No, I need to learn more about that. The other thing is in terms of practicality. So I was talking about my veggie beds. Let's go back to our fruit trees in the orchard and in our community orchard. So we've got these big, beautiful mulch circles. We put compost on around the trees, especially where the feeder roots are at the outer edge of the
Yeah,
canopy every year.
yeah.
And sometimes if we can afford it, we bring in some wood chips or something to put on top to keep the moisture in. But let's say we can't afford wood chips. Would we take leaves as they're not diseased and mulch those trees over the winter? That crucial area in the mulch circle. Would we put leaves there? What are some creative ways? Would we plant cover crop in our mulch circle? I think that might be a problem because unless it dies over the winter, then we're going to be weeding it out and we don't want it to compete with the roots of the tree.
Well, I think that's an interesting point, this idea of competition, because with the Spanish comfrey, for example, it's a perennial crop that you can grow under a fruit tree very successfully. And it doesn't compete. I think the idea of competition sometimes is that, if we've got one plant, it's an either or situation. One plant competes with another. But you often find that the trees actually enjoy the company of perennial plants under them. So one of the strategies you could use would be to find perennial herbs, things that do well in the shade of trees, and use them as a permanent cover crop. You could even, in theory, put fruit bushes there if you were happy to. But the only thing you couldn't do, of course, is put vegetables in that need to be dug up, like potatoes or carrots. So there is
Mhm.
that strategy. The other option, you're talking about putting leaves. I think the only trouble with putting leaves on that are undecomposed is sometimes, well, A, they can blow around, but B, they are very low in nitrogen, and there can be some competition between the degradation of the leaves needing to take up the nitrogen, some robbing of nitrogen from the soil. That could be a potential problem. I'm not sure I'd want to be putting too many fresh leaves around trees. I think I'd want to compost them first. I often find composting them for a year and then reapplying them works better because there's more actually going on in that microbe wise as well.
And so interesting. Okay, now another piece of the puzzle, you mentioned that you do just four foliar sprays. I think
Yeah,
four or five, you said.
4 or
Foliar
5, yeah, depending on the
sprays.
weather. Yeah,
So you're not bringing mulch out because your compost out because it's just too many trees, not practical.
yeah,
You plant them well,
yeah,
and every
yeah,
year you're sprinkling some in the fall, some of the root rock dust around each tree. So that's the
yeah,
loving that the trees are getting. But let's talk
yeah.
about those foliar sprays. What is inside the spray, and what do you think the spray is doing to help your trees?
Well, because we're soil association certified, we are very restricted on what we can use. We can only use products that are actually approved by them. And the one product that we use, and again, I've got no affiliation to MaxiCrop, but we use MaxiCrop Original. That's the one we're allowed to use. And we do a roughly 35 milliliters to 4.5 liters, 7 teaspoons to a gallon kind of application rate. So what that will mean is about 2 to 3 weeks after the fruit's set, I will foliar feed the fruit trees. And then about a month from then, when the fruits are slightly larger, usually in June, I'll do a second spray on the foliage, and then I'll do a third one, normally just before I pick the fruits, and then importantly, I do a post-harvest foliar feed just before the leaves fall off, usually 2 weeks off. And of course, this will vary every year because of the weather and because we do it for different crops, so we do it at different times. But that's the kind of principle that we're doing. Now, your question is, well, what's in it and how does it help the trees? Well, what we know is in seaweed, of course, is some of the nutrients. We have protein-based nitrogen, phosphorus, potassium, so there is a little bit of nutrient there, but nowhere near enough to fund the kind of large yields that we get. So what they're effectively getting is a biostimulant. It's almost like a kind of pick-me-up tonic that just stimulates the trees. If the trees are starting to feel a little bit jaded, a little bit short of manganese, that's the most popular one, a little bit low, they get this tonic. Probably one of the weakest points where they're going out of producing blossom, they're setting their fruit, they're becoming very sort of dominated by the auxins in the fruit. And the cytokinins, which are also in the fruit spray, in the foliar feed, do help to offset that. So we rebalance the kind of hormonal levels in the tree, but we're also topping up things like manganese, potassium possibly, a little bit of calcium. But we very importantly don't put the potassium in before the fruit sets. We make sure the fruit sets first to make sure we get a better size of fruit. Because if we did it earlier than that, it can drive out some of the calcium from the tree embryos. So it's quite
Okay,
interesting. The
so
time is important on the first spray.
the timing is important. So that first
Yeah.
spray was, if I remember correctly, right after blossom time before the
It's a,
fruit has
it's a,
started to form, right?
It's
Or
about 2 weeks after we see the fruit set, 2 weeks. But that will
okay.
depend very much on the weather because, as I said earlier, sometimes it's 4, sometimes it's 5. If we have a very big drought, as we have had this year, we hadn't had really any meaningful rain since February until virtually the third week of May. So that's a very prolonged drought after a very wet winter. So I didn't feel confident doing a foliar feed mid-May, which I wouldn't have normally done. So I'm now doing the first foliar feed first week of June. So we're a little
And
bit behind, and that
and
will
and
have a knock-on effect on the number of sprays.
and so why does moisture in the soil have anything to do with when you're doing the foliar feed? Why does it even matter?
Well, I just feel, and this is based on experience, where you find trees are slightly stressed, when they haven't had water for maybe 3 months, they haven't been irrigated for 3 months, and they're growing, their leaves seem to have a thinner cuticle, they seem to be more drought stressed. They're not stopping growing, but they're just slightly vulnerable. And I have a habit of waiting until we've had some rain before I do my first or second foliar feeds. And I find then I don't get leaf scorch, I don't have any because you're putting a lot of nutrients into leaves which are already stressed. It's a bit like spraying salt on them. It draws more moisture out. It can be it's very stressful for them. So it's a,
Hmm.
it's a kind of observational habit, just wait and see how the trees grow and then spray when you're ready.
I wonder if it's kind of like, I don't know, in humans, if there's a similar thing, like you need nutrition with food and you need hydration. And let's say you're eating too much food and you never drink water.
Yeah,
Maybe it's something like that the food doesn't break down well because you just don't have water to wash it through. I'm not a
yeah.
naturopath or a
No.
dietitian, but I'm assuming that there's some ideal balance, and maybe that's what you're talking about.
I think it's more observation where in the past, I've seen trees or shrubs that are very, very drought stricken, and I've thought, I tell you what, let's do some fertigation. Let's feed it and water it at the same time. And I've actually managed to kill a couple of shrubs doing that over the years in drought. So I'm very wary of seaweed sprays on dry plants. And I think it's an obvious point. So, that's based on past experience. And also the fact that if the tree leaves are quite limp and droopy, which they can be if in an extreme drought, you just don't feel you're going to get much coverage. But we generally see trees doing pretty well in the drought.
Okay, wow. Okay, so we've got a big picture here. We've got the rock dust, we've got keeping the ground covered,
Yeah,
we've got foliar sprays. The one piece that we haven't mentioned is grazing animals in the orchard. And, in my backyard, I don't have cows, I don't have sheep, I don't have chickens. We have squirrels, we have raccoons, and we have bunny
yeah.
rabbits. I don't know if they play a role, but tell me for you what the role of grazing animals is. How does that, complete this puzzle?
Well, I think we've got to consider what grazing ruminants do really well. They selectively go through the grass and they pick out the most nutrient rich leaves, and they digest them, and they excrete urea, and they put obviously dung on the ground. But they're also constantly dropping from their hides and within their droppings and urea a supply of bacteria and fungi. There's a constant recycling, so that's very, very good, and that helps we now know that that makes a massive difference to the microbiome in the soil. And of course, what happens with urea, very interesting, because when urea is our first grazing period starts in November, after the fruits have all been harvested, because we never have animals in the orchard when we're harvesting fruit. But once the fruit's picked, we introduce normally a dwarf sheep, a Portland, which is an antique, we call it a primitive breed, beautiful sheep, very good breed to have. And they come in and they start grazing, and they provide a lot of urea to the soil, which is a protein based of nitrogen. But they're only getting that urea from the grass, which is ultimately extracted from the ground. So we're not adding fresh ureas; we're just putting back what's already the nitrogen budget stays pretty much the same. But that urea can combine with things like zinc and copper, and it makes the blossom a lot hardier, a lot more frost resistant in the spring. And that's very interesting because you can gain, 2 or 3, 4 degrees centigrade worth of frost resistance because you've provided this kind of complex with urea. And the other thing, of course, is that the dung is a great food source for beetles and various sorts of flying insects, particularly in the spring grazing, which follows on in February. And that provides food for things like bats, who are fantastic moth predators for things like codling moths. So I'm very happy with the grazing because not only does it tidy up everywhere, but it also really promotes the soil biology and the soil carbon. And in fact, I think having grazing is a really good way of capturing carbon. It's a very, very good, mob grazing, which is what we do. And we're only allowed to have the sheep in for a defined amount of time a year, 120 days a year. We never get near that. But this restricted grazing is particularly good for carbon capture. So anybody who's thinking that livestock are the cause of global warming should study mob grazing. Joe Salatin and the other people who've been talking this through works really well in commercial growing.
And
So
why
that's
is there a
yeah.
limit? Why is there a limit to 120 days? I mean,
I think well, it's interesting. I think the limit is put there because one of the worries, particularly in the UK, and I'm sure it happens all over the world, is the worry that if you put too much manure on land, particularly near water catchment areas, and the Chilterns is a very famous water catchment for, provides drinking water for huge millions and millions of people. What we do not want to do is pollute that water catchment area with nitrates, and that can come from the over application of slurry, the application of fertilizers, and even organic systems. They can contribute. So it's quite right. You want to calculate how many days you've had your animals on there, and each animal is given a nitrate budget, and we're well within the limit because we just graze so carefully.
when you talk about grazing animals, one of the things that comes to mind is deer. And deer,
Yeah,
I know not, we don't
yeah,
have a problem with it, but in other growers, even, in different parts of Ontario, different around the world,
sure,
they graze on your fruit tree branches. That's not
sure.
good, right? So,
No,
is this a problem you have or you've dealt with?
Yes, funnily enough, because right from the start, I wanted to have grazing animals in the orchards. I mean, it just seems a very traditional thing. I just knew there were great benefits. We didn't know the full benefits, and it's turned out that it was a great idea. But, I wanted to put the sheep in. And the sort of spin-off from that is that we also made it fallow deer proof. The biggest deer that we seem to have locally is a fallow deer, and they will graze up to about 1.5 meters, about 5 feet, which is what the biggest of the sheep that could go in there can get to. So being deer proof is also being sheep proof. And we have a very interesting approach to that, the way we plant and what we use.
But hang on, so you don't have a deer fencing that
We don't
keeps
have
the
deer
sheep
fencing.
in? Okay, yeah.
Well, the fencing only keeps the sheep in. I mean, normally they would use an electric fence anyway to keep the sheep in within the confines of an area. You wouldn't necessarily want to rely on the perimeter fence. I mean, you can do, but it's always a good policy to enclose the sheep within that and preserve hedges, etc. But the deer can easily leap all of that. Deer will leap over a fence that's, maybe 1.5 meters high. They can leap very high. So to make it deer proof would be very, very expensive. So there's two things we do. One is that we have a series of different guard systems. And we've got, a concentric, almost like an onion approach to it. So we've got an outer guard that goes up to 1.5 meters. Then we have an inner tube, which is more of a vole and rabbit guard. And then within that, we'll have a vole guard inside and then the chicken wire at the ground level. And we use rebar as our stake so that if a sheep or a deer buffets the tree, it just springs back. Very, very long lasting stakes. I mean, they go on forever, really. So that's very important. And yeah, deer can't reach our branches. But the second thing we do, apart from all of the kind of hardware, is the way that we prune the trees, which is a narrow canopy system. And that avoids low overhanging branches. So the trees are a lot closer. The deer can't really reach the branches. And yeah, we don't have a problem.
Okay, so let me try and create a picture. In terms of
Yeah.
deer protection, are you removing all the branches below 5 feet and starting your
Yes.
canopy at 5 feet? So harvesting and spraying, everything has to be on ladders.
Well, it's interesting. I mean, the sprayer I use, you can direct a jet up into. I mean, we're only landing droplets on the. We're not spraying the trees. We're just giving them a kind of syringe almost. It's a very old technique of syringing. So we're just syringing the trees. If we don't get every branch, doesn't matter because the nutrient will be translocated through the tree anyway. With regard to harvesting, I'll go up a pair of steps. But we don't let the trees get more than 15 feet or 5 meters high anyway. And you can easily, with orchard three-legged ladders, go up and harvest very comfortably each tree. And because they're narrow, they're very easy to pick from. So you can reach around the tree from one or two positions. So you're not moving ladders around. You're not leaning on the tree. Um, yeah, I mean,
Right.
it's a very old-fashioned system, and we've just brought that back. That narrow canopy system.
Amazing. So narrow canopy, does that mean you start your first scaffold branches or platform or your first side branches at five
Yeah,
feet? And is
yeah.
there more involved? You just let it do what it's from 5 feet to 10 feet, you let it do what it wants, or do you kind of open it up for air circulation when you're pruning?
I think the pruning system is really interesting. What we on some varieties or some cultivars of fruit tree, for example, a lot of the pears, they will decide that they want to have a central branch, or they might make a forked branch. They might have multiple branches. We let them decide. So, I have quite a low intervention approach when I'm pruning in the first 5 years. The most important thing for me actually is blossom removal, but perhaps we can come back to that, which I do myself manually. But the system of the tree growth seems to be dictated by the tree, most of it. And because in the Chilterns we're high, generally we're quite high above sea level. We're about as far from the sea as you can be in the British Isles and the Chilterns. So we benefit from cold units, we benefit from a lot of wind, and it seems to cause the trees to grow in a kind of columnar way. If they don't and they want to spread out, that's fine. They can to a point, but I don't let them spread out beyond approximately, let's say, 8 feet, 8 feet, 2.4 meters. That would be about as much as they would reach out. But generally, I'm clearing branches by year 5. I'm taking out crossing branches in the summer. I only do the pruning in the summer. When you grow trees in the way that we do with our nutrient protocols, you don't get this ridiculous excess growth of trees. You don't get this excess, you get very short internode joints, you get very large leaves, you get a lot of density around the fruit clusters of leaves. the trees just want to fruit very early on. They don't really, they do grow, and there's a nice balance between vegetative and reproductive growth, but they generally don't put on what I would call superfluous growth, that soft, whippy growth that gets, has to be pruned off every year. So yeah, it's a very different. Our trees don't look perhaps like orchard trees that you would expect in a heritage orchard.
I think that is so interesting that how you cultivate your trees will determine how they grow.
Yeah.
The shape, the way they grow. Um, One other question comes to mind. So people listening to this may be very interested to do their own experimentation on their own fruit trees.
Yeah.
And let's say in the past they have used NPK fertilizers. Um,
Hmm.
they probably don't have the organisms in the soil that can digest the rock dust. Can you transition if you already have done maybe some not great things to your trees and you want to go in this natural direction? But is it even possible if you've already killed off the friendly bacteria in the soil that can digest the rock dust?
I think the shortcut, excuse me, the quick way in is to put down some what we would call here green waste compost. So basically, garden compost, low nitrogen compost, not anything with manure in, if possible. So not high nitrogen, something with a lot of fibre, ideally home produced, local, because it'll have your local bugs in. That's part one, and you can mulch that any time of year, apart from when there's snow down, obviously. But when the ground's not frozen, any time of year is a good time to mulch. Not up to the trunk, leave a little gap around the trunk so you don't cause any collar rots. And then put down some rock dust. Just stand back and let nature do the work. I mean, really, I do think we overcomplicate growing. And I'm the same. I used to overquite. Oh, we must feed in this. All about the right pruning. But actually, when you strip it back and look at first principles, a lot of natural growing. If you go into a wood and you look at how a tree grows, it just grows brilliantly and it's very productive. I think we need to simplify growing, and that's the joy of being biological, being organic. Natural. Um, you can convert your land back pretty fast. The bugs will come in very fast.
You had mentioned to me in a previous conversation, and it really made me feel so hopeful. You said this is a very exciting time for agriculture in the United
Absolutely,
Kingdom
it really
and
is.
and possibly around the world. Why? Why is it so exciting? Why am I excited to be a part of this?
Well, I mean, part of it is the technological advances that have allowed this podcast to happen. I mean, the chances of us meeting each other in the natural sort of world of the 1980s, the 1990s, is pretty difficult. Now, we can exchange information, we can talk to people, we can learn very quickly. The great work you do, educating people, you can spread information, and things happen very quickly. That's great. So that's good. So I think that's a very exciting opportunity. But I also think, the fantastic discoveries that people are making about soil biology. I was a student in the 1980s, early 90s, and soil biology was really in its infancy, and we didn't talk about it. We didn't think of the soil as a living entity, having an ecology of its own. And most importantly, we didn't realize the effect that that has on plant health and therefore the cost of growing. So I think if you can persuade yourself to forget maybe some of the things you learned in the past, you open up a little bit to the idea of being a biological grower. And some people will never be organic. I think if you are organic, you'll find you cut your costs and things get a lot easier. That's definitely what I would say. You solve a lot of problems very quickly. But even if you can't do that for various reasons, if you just take on the most of the regenerative practices, um, your profitability goes up. Well, that's very exciting for farmers who are struggling. And if you're worried about, ecology, you're worried about species extinction, if you're worried about global warming, if you're worried about food security, all the things that we talk a lot about are actually, they're just under our nose. And I feel very lucky because I've been able to do a lot of growing for people and really share it with them. And I think it is very exciting, absolutely exciting. And, we've only just really just started.
Amazing. Is there any last words that you would love to share with listeners to this show who are home growers, who are small scale orchardists, arborists? What would you say to them?
I would say to them, grow as many cultivars as you can. I think that's very important. We've saved many very, very valuable, useful economically, very successfully in the past grown crops. Definitely don't fall into the trap of monoculture. Be diverse, be very, very experimental, and let biology do the heavy lifting for you. It's a free service. You've got every right to use it.
Everybody loves free stuff. There you go.
Yeah.
Lindsay, how can people learn more about you? Do you have a website or social
Yeah.
media?
Well, we do actually. ChilternHeritageOrchards.com is our website. We are on Instagram, Chiltern Heritage Orchards. Yeah, we're on YouTube. We have a great YouTube channel. It's great because it's basically a journal. And I have my own Instagram as well, Engers Lindsay, which is just a kind of update every so often of the work we do and the things we do and the people we meet. Check us out because we are literally journaling what we do, and we're very happy to share that with people if it helps them. That's fantastic. And we really, really appreciate your interest in our work.
I loved the videos. I watched some of them, and I think there's a lot of really useful information in there. So I would highly recommend people go to Lindsay's YouTube channel. Very much worth it. We will have lots of information in the show notes today. We're going to have links to Lindsay's website. Also, there will be a link to an article. So now what we're doing is every month, once when we do a show, we turn it into a detailed article with the highlights of the show. So if you're a reader rather than a listener, you can see more information there. Finally, if you liked this episode, I would love it if you could click on the like button and the subscribe button so that we can continue providing you with really great information and wonderful interviews with people like Lindsay. Lindsay, thank you so much for coming on the show today. I hope you will come back. I think that there's going to be more things that we can talk about in the future.
Thank you. That's great. No, I really, really enjoyed today and so grateful for all your attention. Thank you very much.
Thank you. So, for the listeners, if you want more information from me, go to orchardpeople.com and sign up for our newsletter. And that's all for today's episode. I hope you're going to join me again next month when we dig into another great fruit tree care topic. I'll see you then, and goodbye for now.